ASML, based in the Netherlands, holds an absolute monopoly on extreme ultraviolet EUV lithography, the only technology capable of printing nanoscopic transistor patterns required by advanced chips from NVIDIA, Apple, and TSMC. The next leap forward is high numerical aperture, high NA EUV, a machine that is larger than a double-decker bus, costs around $400 million per unit, uses a wider lens opening to capture light at steeper angles. This allows higher resolution, fewer manufacturing steps, lower long-term costs, and faster production. The process itself is almost science fiction. A powerful CO2 laser is fired at molten tin droplets, creating plasma hotter than the surface of the sun. The EUV light then reflects off the flattest mirrors ever made by humanity before etching patterns onto silicon wafers. From a geopolitical perspective, it matters greatly that the first high-NA machine was installed at Intel's Oregon fab. ASML is opening a major training center in Arizona. This signals a deliberate effort by the United States to pull critical expertise and infrastructure closer to home, even if it does not control the technology itself. 2. Texas Instruments, a quiet but foundational strategy. Unlike Intel or TSMC, Texas Instruments, TI, is pursuing a less visible but deeply strategic path. TI's $60 billion investment in 7 U.S. fabs, 4 of them in Sherman, Texas, is not about 3-nanometer logic chips. It is about analog and embedded semiconductors, the chips that manage power, control sensors, enable cars, industrial machines, data centers, and smartphones to function. The pandemic taught a hard lesson. Without older chips, the modern economy grinds to a halt. By shifting production to 300mm wafers, TI gains a 2.3 times output advantage, creating long-term cost leadership. These fabs are also designed for 100% renewable energy, up to 80% water recycling, redundant power systems to survive grid disruptions. This is not just manufacturing, it is industrial resilience by design. 3. Apple, total control of silicon and on-device AI. Apple's strategy operates at the level of vertical integration and ecosystem control. The new A19 Pro chip marks a major shift. Neural accelerators embedded directly into each GPU core. Seamless switching between graphics rendering and AI computation. AI performance approaching MacBook Pro levels on a smartphone. Apple's emphasis on-device AI is intentional. It prioritizes user privacy, low latency, energy efficiency. Perhaps most significant is Apple's move to eliminate dependency on external chip suppliers. Its first in-house wireless and Bluetooth chip, N1, the new C1X modem, reportedly 30% more energy efficient than previous generations. Yet, there is a strategic contradiction. The A19 Pro is still manufactured on TSMC's 3-nanometer node in Taiwan. This highlights a critical vulnerability. The world's most advanced chips remain tied to East Asian geopolitical stability. Final assessment. The central message of this video is clear. The semiconductor race is no longer about who is fastest, but who is most resilient. ASML controls the world's most critical manufacturing bottleneck. Texas Instruments strengthens the industrial backbone few people notice. Apple secures AI performance directly in the hands of users. But as long as the most advanced manufacturing remains concentrated in Taiwan, global supply chains remain fragile. In the age of AI, semiconductors are no longer just components. They are the strategic power of the 21st century.